Hello everyone, I'm Siddharthan. In this video, let's build a data visualizer web app using Streamlit where the user can select a dataset and they can choose the appropriate columns, and based on that columns they can build the plots that they want. So in this example, I've chosen the diabetes prediction dataset, and here you can see the sample of this dataset with all the columns that's present over there, and then we can select, let's say, the x-axis column as age, and then let's build a distribution plot. So we don't need like an y-axis as another column, so I give this none as the option, and select this distribution plot among the other plots that I have, and I'll give this generate plot button. And now we would see this distribution plot built with a KDE curve on this dataset where we have this age column in the x-axis and the corresponding density in the y-axis. So this is how you can build this plot. So you can also, let's say, choose some other dataset. Let's say we have this art disease prediction dataset, and here you are choosing your target as your column, and let's say here we have over this age, right? So I'll choose this none, and let's build a count plot where we don't need two columns and generate this plot. So this is a count plot. So similarly, you can also build line plot with two columns, bar chart, or even scattered plot. So this is what we are going to build in today's video, and let's discuss about it. So here I have my PyCharm open. I'll give this code in the repository. You can refer that in the video description. So you need these libraries in order to build this Streamlit app. So first you need the Streamlit, and I've also given the appropriate versions that I'm using, and I have this NumPy, Pandas library, Matplotlib, and Seaborn, and these two will be used to build our plots. Now let's see how we can build this plot. And I also have this data folder where I have all these data sets, right? So these are the data sets that will be shown to you in the drop down, and you can kind of do this like in a better way as well. Let's say that you have the dataset files stored in your Google Drive. So using Python, you can link to that particular folder of your Google Drive account, and you can list the files there. And once the user has clicked that particular dataset, right, you can retrieve that from Google Drive and then build the plots for that. Similarly, you can put the data files in S3 bucket in AWS or storage account in Azure and kind of work on it to have like a more better system. So that's about it. Now let's just have this in a folder called as data, from which our Streamlit app will access this. So this is the code repository which I'll share it to you. So you have this requirements.txt file. So first step is make sure that you install all the required dependencies. So for that you can run this pip install r requirements.txt. So this is my project directory, and I have this requirements file over here. So I'll run this, and I've already installed the libraries as you can see here. Now we can get into the coding part. So first I'll import the basic libraries such as OS, and I'll import pandas to read the CSV file as a data frame. I'll import pandas as PD as we usually do, and then let's import matplotlib dot pyplot as PLT, and import Seaborn as SNS, and finally we can import Streamlit, right? So okay, this is like the usual standard that we follow. So all the default or like inbuilt directories you can import at first. You can like give a space and then import all the other libraries that you have installed and you're going to work on. Let's say that you have custom files. Let's say that you have created a function and put that in a file called as custom function.py. So that you can import it like after a couple of lines over here. So this is like a standard that you can follow. So here we don't have any custom files. So this is the imports that I'm doing. Now we can set the page configuration. So I'll say set page configuration. So here I'm going to say st dot set st. It's basically we should import Streamlit as st, and now I'll say st dot set page config, and here we can say page title. So page title will be let's say data visualizer, and the next parameter that we can give is layout. So layout, I'm going with a centered layout. So the other option is a wide layout, where again, so the entire content of your web app will be kind of fitted to your entire screen. So I'm just going with centered layout. You can kind of go with that as well. And then you have this page icon, And here you can kind of choose some emojis. You can use favicon icons, or you can just go to Google and search like this bar chart is what I'm going to use. I'm giving this bar chart emoji, and you have this Emojipedia thing, and here I'll go and copy this emoji and paste it over here. So this is what will be appearing in your kind of tab. So here you're seeing some icons and the name of the page here, right? So similarly, our Streamlit web app will have this particular icon, and the title will be data visualizer. And now let's give the title for our Streamlit app. So I'll call this title, and here let's say st.title. Close this maybe. Okay, so yeah, st.title, and here let's also maybe put this icon again and call this the same thing, data visualizer. You can call this web app, or you can just leave it as such, right? So anything you want. So you can give any names, or you can give some fancy names as well. So this is the first thing that we are building. So in order to run the Streamlit app, you can just say Streamlit space run main.py, because main.py is the file where we have all these codes. So make sure that you have also installed Streamlit. So this will open this web page where we can access this. So here you can see this page icon and the page name, and also you have this data visualizer web app. So this is like the initial base app. So again, this is in like the centered layout, so that's why you're seeing this name on the center of this page. Now we can build the other things. So the next thing that I'm doing is setting up the working directory. So working dir is equal to os.path dot directory name, and within that I'm going to give this os.path dot absolute path file. So the importance of this is, right, so we need to access the data sets that we have over here in this data folder. And when you're working with Streamlit, so this won't be your default working directory. So when you want to access some files, you need to give the kind of full path of this, let's say diabetes CSV, art disease CSV, and so on. But I don't want to copy like this exact name, because if you are running this code, right, you may have to change this. So I don't want to hard code this path. So instead what I'm doing is I'm getting the absolute path of the file. So in this case, the file is nothing but the main.py. So this will give the absolute path of this file's directory. So if you see here, we are getting the directory name of this file. So this actually returns you the path of this dataviz rec folder. So that directory, and later within that we can join this data and all these dataset files, so that even if you run this code in your PC, it should work without any issues, because we are not hard coding the path. So that's the other thing. So this is for setting up the working directory, or not, but just like getting the working directory of, let's say, the main.py file. And now the next step is giving the folder path, which is this data, right? So here I'll call this as folder path is equal to if, so we can substitute the string over here as working directory, which is this, and then we need to mention this data folder, right? So I'll just put a slash and say data. So this is my folder that contains like all the files that we have over here, and then we need to list all the files. So this is basically used in order to list all the file names that we have in the drop down. So let's do that. List the files present in data folder. Okay, so that will be the next step. So for this, I'll say files is equal to, so this is a list, and this list will be f for f in os.list dir folder path, if f dot ends with .csv. So let's try to understand this. So here we have a for loop, and what we are basically doing here is we have this folder path, right, and using this os.list directory. So this function will basically return all the files in a directory. So in this case it's data, right? So this will return all the files in this directory, but it will just return you only the files that are ending with .csv. So let's say that you have Excel files, those things won't be detected here, because we are listing only the CSV files. So what you can do is, instead you can kind of include CSV files as well as Excel files, and you can ignore like other files that you have, so that your web app will kind of work with both CSV and Excel files. So that's the other thing. So here we have this list directory thing. Okay, so files, so this F for file and range. So for each file name, if it's kind of ending with .csv, we are putting that in a list. So when this line is executed, you basically get a list that contains names of all these files, and these names we will be putting in the drop down that we have seen. So here I'll call this as drop down for all the files. So from this the user can select a file. So I'll call this as selected file as, let's say, the variable. Selected file is equal to st.select box. So this is like a single selection. So you also have like multiple selection option in Streamlit, but we just need like a single selection. So here you can say that select a file. So this will be like displayed in the screen. And next what you should do is give the list of files. So the files, this is the list, right? Maybe I can call this as files list and paste it over here. And index is equal to none. So index is basically like when the user kind of refreshes the page, or when they are in the page for the first time, we don't want to select any files by default. So if you want to select a file by default, you can put 0, 1, 2 or 3, like based on that, like a particular file will be chosen by default. So we don't need that. So I'm giving this index is equal to none. And then if a particular file is selected, we can kind of do something there, or we can maybe run this. I'll refresh this page, so this will refresh the code that we have, and now you can see this. So this says like select a file, which is the string that we have, and now you have a drop down which lists all the files that we have in this directory, right? So you can kind of choose one. So that file name will be stored in the selected file. So I can also show this to you by writing this st.write, which basically displays a string, and here I'll call this selected file. So it's none because initially nothing is chosen there, right? So now I'll give this diabetes.csv. You can see over here. Now, once the user has kind of selected a particular file, we are going to give the path of that file, read it, and then build the corresponding plots that we need. So that's the next step. So here I'll say if selected file. It's basically like initially it will be none. So when it's none, this if block shouldn't run. If it's not none, that means if a file is selected, then this particular code snippet will run. So that's the kind of purpose of this if condition. So here we are going to get the complete path of the selected file. So here we already have the folder path with this folder path, right? And then we can just concatenate this file name to get the entire path. So for that you can just do a file path. This is a variable. So file path is equal to os.path.join. So we are just joining the path of the folder and the file. So I'll call this folder path comma selected file. Okay, so we are just combining the folder complete like folder directory complete path and then the name of the file, and then now we can read this. So reading the CSV file as a pandas data frame. So here I can say df is equal to pd dot read CSV, and here we can give the file path. And yeah, you can also display this kind of a sample of this data frame which we have seen, and for that I'll do this column 1 and column 2. This is just to align like all the selection bars that we have and the sample data frame that we want to display. So here I'll create two columns as column 1 and column 2, which is equal to st.columns, and here I should pass 2 because we have two columns. If you have column 3, you should put 3 here. And now I can say with column 1, so we need to display this st.write. So I just want a line space here, so I'll just create a st.write with a null string and then do a st.write df.date. So if you want like 10 rows, you can put 10, but I'm just good with like 5 rows. I'll just go with this 5 rows alone. So maybe we can run this and see. Refresh the Streamlit tab. So nothing is selected first, but when you select a file, we can see the sample over here. So we can see this is like in this first column, first of the screen, right? So that's why we meant this or use this column one thing, right? The next step is here we need to build that column name selection where the user can select like x-axis and y-axis and the plot as well. So for that we can use the column 2, but before that you need to get all the column names to display it over there. So here I'll say columns is equal to df dot columns dot to list. So this will kind of create a list that contains names of the columns of the file that the user has selected. Now we are going to pass this over here. So here I'll say with column 2, this is for user selection of df columns. Let's have this x-axis is equal to st dot select box. Say select the x-axis, and then within this options parameter we can give this columns, but this is a list, right? To this I'm going to add another, let's say, variable or basically another string called as none, because in the case of distribution plots and count plots you don't need two columns, you just need only one column, right? So for that purpose we can have this none. So here in this columns I'll add this none. So columns is a list, and plus I'll add this none string. Similarly we can kind of have this y-axis. Okay, so here select the y-axis, and now we can give the list of plots that the user want to select. So here I'll create a list called as plot list, which is equal to line plot. Let's say next we add a bar chart, right? So I'll call this as bar chart scatter plot. So you can again include other plots as well. So for demo I'm just like choosing like minimal plots, and let's say we have a distribution plot, and finally we have a count plot. Now this is like the user selection thing. So here let's maybe call this as plot type, the type that the user has chosen, or maybe we can call this a selected plot as well. So selected plot is equal to st dot again a select box, select a plot, and options will be plot list. Okay, so if you want you can similarly give an index, so that basically doesn't have any values by default, but here I'm not mentioning that. So what would happen is by default some column name or basically the first column names will be selected over there, and later for just reference, right? So I'll just print this or write this x-axis, y-axis, and plot type. So yeah, selected plot, right? Maybe we can have this index as well, so it's not a bad thing. So I'll call this index is equal to none. So similarly we should have it over here, right? So now let's refresh this page and see until the part that we have built. So nothing is selected at first, so we have this data visualizer web app, and now I'm choosing the diabetes.csv file. You are seeing this data set kind of like sample over here, and you are seeing this x-axis, right? So in the x-axis, let's say that I'm choosing pregnancies, and in the y-axis I'm choosing, let's say, insulin, and in the plot I'm choosing this count plot. Okay, so it says I've mentioned like x-axis over here, that's why it kind of printed the same thing. But yeah, so that's the idea. So once the user has clicked like those corresponding x-axis, y-axis, and count plot, we'll be storing that in the respective variables. So this will be stored in x-axis variable, this is y-axis variable, and this is like selected plot variable. And later using a if condition we can choose the plot that we want to display. So now we can have a button, but this doesn't have to go into the columns. So you can come out of this with column, where we had this with column 1 and column 2. So here I'll say that this is a button to generate plots. So if st.button, so when a button is clicked, this will return a true, and this if condition will be executed. So I'll call this generate plot. And here let's create this figure comma axis. This is like the usual way that we use to build plots in matplotlib and seaborn. So I'll call this plt, which is like matplotlib.pyplot, plt.subplots. Within this, you can also mention the figure size. I can mention the, let's say, the figure size as 6,4, which was like pretty okay for me. So what would happen in this case is when you do this plt.subplots, so this will create a figure under base axis, and on top of this figure and the axis, we are going to build the line plot distribution and the other plots using seaborn, which is like a really good library for like building these kind of plots. So here, this is the base plot, right? And next we say if selected plot is equal to line plot, which we have over here. So if the user has selected this, we need to write the code in order to build this line plot. So here I'll say sns dot line plot. We need to give the x-axis value and y-axis value. So that parameter for giving the x-axis value is x. So here I'll say df. So df is the data frame that we are reading, which is the user has selected. And here we need to mention the column name. So the x-axis column name that the user is selected is stored in this x-axis variable. So I'll give it here. And y-axis value should be passed to this parameter y. And for this we can give df of y-axis. And finally you can give this axis ax is equal to x. This is like a standard thing that you can use, right? So this is how you can build a line plot. So similarly, again, it's the same thing if you want to do a bar chart and all those things. Maybe I'll just copy and paste these things quickly, and then right, first is line plot and the next one is a bar chart, right? So I'll copy this. So if the user has selected a bar chart, we need to build a bar plot. So that will be called as sns dot bar plot. Again, those things wouldn't change, it's the same. And finally we have the scatter plot before distribution and the count plot. So here I'll paste this and it will be sns dot scatter plot. Okay, and then we have distribution plot and the count plot. So this is a bit different from the other plots because distribution and kind of this count plot doesn't need like two columns. We are just going to do this distribution or count plot only in one columns. So similarly you can build other plots as well, like you can build the correlation matrix of this data frame, or again go with like other interactive plots that kind of gives you better value. So here I'll just build this distribution plot. For distribution plots you need to say histogram plot, and then in the data I need to give this df of axis. So the x-axis will be chosen here and the y-axis will be none. So the idea or the reason we add this none over here, the string, is the user should select a particular column in the x-axis, and the y-axis they should choose none. So we have this df of x-axis, and then kde is equal to true. So this basically smoothens the noise and just draw a curve over the histograms that we have. And then in axis is equal to axis, and in the y-axis name we have to mention something called as density, or maybe we can look at it a bit later. And then you have a count plot which kind of also like a similar code. So this should be a count plot, and it will be count plot, and we need to change all these if condition to else if condition. Okay, So now we have the 5 plots that we want to build, and finally we can kind of build these labels and the names of all these things and so on. So here I'll call this adjust label sizes, the x-axis and y-axis labels. So for this you can call this axis and say tick parameters. Yeah, x dot ticks params, and axis is equal to x. So this is like the x-axis parameter, and I want to have this label size as, let's say, 10. You can again change this to a different number and see like how large the fonts are. These are like some basic things. You can like skip these as well, but it's better if you kind of do these customizations as well. And then let's kind of build the title uh, for the plots as well. Let's call this, and basically your x-axis names and the y-axis name title, and let's call this axis labels plt.title. So here I'm going to say f of plot type. So I want to take these names from the plots that the user has chosen. So that would be selected plot. So we won't be hard coding this. So let's say if they have chosen a distribution plot, so that's what we'll give in the title. So distribution plot of y-axis versus x-axis. So we are not hard coding this. And you can also call the font size over here. Let's say the font size is equal to 12. So these are the sizes that worked well for me, so I'm just going with this one. And for plt.x label, we need to pass a string, but this string is again the one that the user has chosen as x-axis. And here also I can give the font size. Font size is, let's say, 10. And then we have a y label. Finally, we can show this plots by using Streamlit's st.pyplot, and here I'll call this figure. So that is all. This figure is basically the base figure that we have created. So let's delete these things and run our code again. So I'll refresh this. Okay, so now let's choose this art.csv. We're still seeing this none, so I need to remove this st.write things. That's just for a debugging thing. So let's refresh this. I'll choose this art.csv. So you're seeing like the sample of this data frame, head of this data frame, and I'll choose the x-axis as age, and let's say that I want to build a distribution plot. So for this, I'm going to say y-axis is none, and the plot that I'm going to build is a distribution plot. So let's generate this plot. And this is how we see this. So we have this KD curve thing, which smoothen the distribution. We are seeing the histograms. So we are basically seeing that we have more data points around the age of, let's see, 55 to 65 and so on. So this is how you can build a distribution plot. And let's say that you want to, let's say, build a scatter plot of age in the x-axis and something. Let's say this, I think this is the cholesterol value. Let's say that we have a scatter plot and generate a plot over here. So this is a scatter plot you're seeing over here. So similarly, you can build different plots. This is again for a user who doesn't have that much knowledge on how to write the codes to build these plots and so on. So for them, you can basically build a simple web app where they can kind of choose the data set that they are working on and kind of like choose the plots that they want to see. Let's say that we want to see the count plot for the target variable to make sure that, let's say, there is no class imbalance. You can build a count plot. It's KDE. Okay, I think I didn't remove that KDE because KDE should be there only in the distribution plot. Yeah, that's right. Now let's run this again. So here I'll choose target. Y-axis should be none. And this is a count plot. Generate this plot. Okay. This is not right. So we need to look what's going wrong. I think I need to give this to the x parameter. Okay, yeah, that's the problem. So here I need to say sns.count.x is equal to df of x-axis. That's right. So this should work well now. So r.csv, uh, this is my target variable. Y-axis should be none, and a count plot. Right, so now we are seeing this. So for class 0, which is not having any RDisease, we have about 140 data points, and for class 1, that is a person with the RDisease, we are having about 160 data points. So the class is like the data is not having any imbalanced distribution. So this is how you can build a simple data visualizer, a web app using Streamlit. So if you want to make this a public app, you can easily put all these codes in GitHub repository, connect to Streamlit Cloud. So I've already made videos on that, so you can refer to that. So this is how you can build this data visualizer. Again, this is just like a simple version of this. You can add more plots to this, make these kind of like more advanced by adding like more features to this, where the user kind of has like an easier way to build all these plots and make a analysis out of this. Okay, so that's it from my side, and I'll see you in the next upload. Thanks for watching.